because you're not going to work for this person regardless. So, trying to get other people.
No, is that just for
that's just like identity. Yeah. With wind chill, let's feel like negative 75. That much.
It was fine.
Times the slow can come classified on its
It's just once.
Yeah, I saw that. They had like at the time, and it was like
I think it's like going to the hyper. The hyper lock you can't post it. For the ground.
last night when we were going out.
Have all of our terms in?
Some
It's cold. It's cold outside. There's places much colder than this here today.
Chicago.
Chicago, 48. Right? Right? That's when my family's come from Alaska. And they're like, so yeah, we're ready to go home where it's warm. They're here now. Oh no, they came down. They had a baby. So they came down to see me, baby. Yeah, they don't. They winter down here and then they summer. Better way to do it. Yeah. Except now, because now our winter is actually colder than it seems to be up there. So, and we're not prepared. That was the other thing. They're like up there, at least we're prepared for things. Here, it's like you guys all have jackets, right? Coats. Just making sure. If you don't, talk to me after. All right. So today we're back on data mining. Business intelligence, knowledge management. I really should just change the slide and just make it data mining. But big adventure for today. First, we start out with the fun questions from last week. You guys have any questions from last week? Do you remember what we did last week? Today, you got an assignment due about it. Like, hopefully you took your quiz about it. You got an assignment due about it today. So hopefully you have a little. Have any questions about your assignment, your quiz? Really? Okay. The big plan for today is going to be, we're going to do a little show and tell. So I hope you've at least started on assignment 2. I looked and a whopping 3 of you have turned it in. It's not just a midnight, you're too. You've got time. We're going to do a little show and tell for assignment 2. We're going to talk about the concept of variable selection. We're going to talk about linear regression with the idea of prediction versus explanation. And do a little bit of transition talk there. Then the whole idea that why I'm using linear regression as our first thing, and hopefully you already know it at least a little bit, because I taught it. It's using it as an estimation technique for us to talk about model performance, and that'll be a big part of our model performance. I have discussed projects. Really, the only thing there is just checking in with you guys. We all have our team set up. Everything's good to go. And just being detailed on the data set. So that's kind of our big thing for today. So, where have we been? Just making sure that we're good with all of our verbiage. We've got 2 different data mining processes that we're talking about. And we have 2 different categories that we talked about, 2 big categories. And so far within our categories, we have different tasks. Right? The estimation, the classification. Those are the 2 big ones we focused on. Then we'll have clustering, association, and description as well. So far, we've talked about, what have we talked about? Right, we've hit this. Right, We like the crisp process. In fact, I'm going to encourage you to use the crisp process as you start assignment 3. We talked about our different data mining categories. So far, we've really done an unsupervised task. And you guys were focusing on visualization. So we're in the unsupervised category with the description task. It's kind of been where we've been at this point. Today, we're going to still focus on that crisp process. We're going to hit our first supervised, and we're going to focus on an estimation task. So that's going to be today. So where we've been, we've really been doing the data understanding and the data preparation phase. Right? So we've been assessing the quality of our data. Obviously there was errors because I put it in. We've been performing some exploratory data analysis via visualization. Hopefully for this last assignment you were fixing your errors, so you were in the data preparation phase, you were cleansing it, you were preparing it. Probably not ready to transform anything yet. We haven't gotten to a point where we need that yet. And then this is actually what we're going to work on today, is selecting the variables that are going to be appropriate for our analysis. That's going to be our variable selection piece. Like I said, so far, and this is one of the slides that we'll just fill out every week. So far we've done unsupervised visualization. Today we're going to add in that supervised multiple linear regression. So where we are today, like I said, variable selection, linear regression, model performance. These are our big 3 things. We're going to be hitting the business understanding phase, the data prep phase, modeling phase, the evaluation phase. All of those things we're going to talk about in context of linear regression today. But before we get to that, sometimes I just like to pause for effect. Questions for you guys. So we had assignment 1, you guys all found the error in the data. For assignment 2, this due tonight, you've been cleaning your data. And so one of the questions I have is, how did you clean your data? Excel. Okay. So what did you use Excel? Anybody not use Excel? I didn't put a condition on it. I think Python. Excel, Python. Is that nobody wanted to play with that? That's okay. It doesn't break my heart. Okay, maybe it breaks a little bit. No, I'm all for using the tool that works the best for what you need to do. Right? So you have a small data set. You're familiar with your Excel skills. Go ahead, use Excel, fix what you need to fix, move on, right? We'll learn how to do different things in different softwares as we go. How did you add your new variable? Excel. Anybody do anything besides Excel? Equals this column plus this column plus this column. Okay, great.
I use SASFly, but then realized that I have to redo it in all the tools. So.
And so that's a fun point. He makes a very good point. So I'm like, hey, try all these different softwares, but then you're like, well, yeah, but now I'm data cleaning in this software, and I'm data cleaning in this software, and I'm data cleaning in this software. So ideally, so at the beginning and kind of why we were doing assignment 2 was really just to get you familiar with the softwares. That was the goal. If you came up with amazing visualizations, that's great. If all you gave me were bar charts, that's okay too. Yes. Okay. So the point for this assignment wasn't major insights, right? It really was, let's take something simple that you guys are familiar with, and you know what looks good and what doesn't, and let's look at the different softwares, get acquainted with them, and be like, I'm not going to use Enterprise Miner to make visualizations because, ew. Is that a consensus? Yeah. Right? Enterprise Miner is just not the thing.
It wasn't very intuitive.
So it wasn't intuitive. And on top of not being intuitive, how the graphs look when you were finished. You're like, I would not show this to anyone. Okay. So do show it to me. I want to see at least 2. Okay. But if they're horrible, that's okay. So like I said, the point for this was just something very basic just to get you into the software, get you working with it. And that really was the point. It wasn't necessarily to come up with the biggest, best, brightest visualizations. But, saying that, so that's our data that we were playing with. We were playing with our trend data. What I actually want you to do, just for a few minutes, is I do want to see what visualizations you came up with. Okay. So out of all the playing and all the things that you've done, if you will get into Blackboard, and we're going to take about 10-15 minutes to do this. I promise it becomes more interesting. Okay, so if you'll get into Blackboard, somewhere in the course that you guys are in, on the discussion board, you'll find a forum for classwork. So go ahead and get into the classwork forum. And then I've started a thread that says visualizations with today's date. Go ahead and click on that one. And then really what I want you to do is I want you to reply to this thread with your favorite visualization from assignment 2. So hopefully by this point you've at least done one. What I recommend that you do, open up your assignment 2, select a visualization, save as somewhere, save it on your desktop, save it somewhere easy real quick to look. And then when you reply to this thread, and you can select down on the bottom, the second one over, it says edit image, or insert image, and then just insert the image. I don't need any text, I don't need anything that goes with it, I'm just looking for the visualization. And if you'll wait for 1 second, let me fix one thing before we do this. Did you already do it? Don't do it. Deciding which visualization you think is your favorite. So now you should be able to go into classwork, go into visualizations. And this part is totally up to you. When you reply, you're going to insert an image. And then if you want to, you have the option to post this message as anonymous. Okay. So if you want to put your name out there and be like, yeah, this is mine, put it out there. If you're like, I'm just doing this because I have to, you're welcome to post the message as anonymous. Okay. So this isn't going to be a graded thing. It's going to be more of a, you're here and you're participating, and I'm going to count and make sure I have 20 of them, and life is good, right? But I just kind of want to see what kind of graphs you came up with, what kind of visualizations you came up with the different tools.
So you don't need to make any comments?
You don't have to make any comments, just the visualization is going to speak for itself.
For better or for worse?
For better or for worse, the visualization is going to speak for itself. Alright, so whenever you're ready, go ahead and start replying. Again, if you want to make it anonymous, you're welcome to do that. So I like the active. Kind of see what insights is found. See if people were really creative and started putting a lot of things. Yeah. See if y'all stuck with the handy dandy bar chart. Alright, we're up to 7. We're doing good. Should I do it? No. I'll do it.
Oh, you can do whatever you want. It doesn't matter. Anonymous.
I feel like she could probably see. Like, I was just
think it's so much like
Alright, we're up to 10, we're getting there. So just reply with the visualization. Any of them, whichever one's your favorite. And we'll just start kind of looking at them, because that's the fun part. So some of them will pop up in here, some will pop up when we'll actually have to click on them, but that's okay. My thought here is several fold. I'm not going to look at all of them yet. We're going to wait till everybody gets... Start to 12. We're getting there. Need about 8 more. So I still hear some clicking, so we're good. Kind of the goal here is I ask you for your favorite visualization, so we'll see which software people are like, this is what I like. We may see just, again, it may be simplistic. We'd be like, this is the thing that had the key piece of information.
Yeah. I mean, maybe the most of us. I like Sapphire was my favorite. I got mad at the idea that it didn't center it, so it's impossible.
13.
Space 12. Yeah, like half of them were centered. And the
Does anybody have any issues uploading their? You guys are already looking at them.
People have shared their actual.
Nope, slow it down.
Oh yeah, Courtney. I makes it bigger. It doesn't show anything. Oh, it does.
Alright, one more. We're getting there. I'll give you guys about 1 more minute to get it all posted. Let me know if you need help. We go back into our forum, and you guys are going to be able to look at it. And look, I don't even have to give you directions, and you're already starting to give like little stars. So no, you don't have to rate them, but you can if you want to. So as you're going, especially if you find and you're like, oh, I really, really like this one, you know, give it some stars. You're like, oh no, this is not it. Okay. The stars mean absolutely nothing, other than, hey, we like this visualization or we don't. But so let's kind of look at some of these. So here we have a box and whisker plot with a bunch of dots. What do we think about this one? So it's made in Tableau, so Tableau's a good one. Do you like the box and whisker plots? So we're talking about the number of international calls and if they have an international plan or not. What's something you really like about this graph?
Shows that there's no kind of normal distribution.
Okay, so you're getting the distribution. Nice and kind of evenly spread out. I actually kind of like that you have little dots as well, instead of just the lines. I really like there's a title. This person actually took the time to put a title in with it. So whoever you are, anonymous. Okay, let's try another one. What do we think about this one? Average charge by state. So again, we got a title. I know what I'm looking at now. Do what?
What's going on in India?
what is happening in Indiana. Okay, so we got the darks over here in Indiana, looking a little maybe Maryland. So my question that I posed as I was grading these for my Saturday class is, how important is Alaska and Hawaii to your visualization? Right, it's like Alaska, and then the rest of the United States. So if you have data about Alaska and Hawaii, can you choose not to use that data when you're making visualizations?
Yeah.
Somebody may be offended.
Somebody will get offended. Right, so this is.
Someone in class who can get
That's disrespectful.
I mean, I've got family there. I sympathize with you, right?
Alaska,
Can you
so
have
big
it
and
get a subset?
You could, yeah.
It's not that big.
So like sometimes people will start to. You'll see like Alaska, and you'll cut it, and it'll be like in a little box off to the side, or Hawaii, off kind of like right next to each other off to the side. And that's the crazy thing about the U.S., right? There's not a lot of other countries who are split with another country in the middle. Right? So this is why you'll see a lot of things that are just of the contiguous, 48 states. And we're not counting Puerto Rico because it's weird. But yeah, so that's just one of the things to think about. Just because it's in your data set, if it's not helping your story, right? Because there's anything interesting happening in Alaska or Hawaii. Right? If it was, right, like if Alaska was the darkest state, you can't leave that off. Right? But since it's just kind of in the same colors as most of the others, maybe for your visualization so you can see the states better. I'm not picking on you, you just have to be the first one with
you're
pictures.
good. Just help me with my assignment.
You're like, yes. And that's kind of the idea too, right? These are some of the things that I picked out from the Saturday class. So we're going to talk about. Also, not going to lie, makes my grading go faster. You guys fix things. All of your assignment 1 should be graded. Some of them were graded, well, at this point, 45 minutes ago. But all of your assignment 1s are graded. Everybody did really well. You'll see some comments on some of them. If it has a reference to A2 and you fix it, great. If not, and I just gave it back to you this morning and you don't get it fixed, that's okay too. What do we think about this one? Things we like, other things we'd like to see added.
It's kind of hard to tell what's happening in space.
Okay, so over here the bubbles are overlapping, we're not sure what's happening. So what is the bubble representing?
Or is it charged to?
Okay, so is it customer service calls? Is it the charge total? So what?
The colors on the side. Yeah, the colors are charged and the size.
Okay, so the color is the charge, and then the size is the number of customer service calls. Is there a way to make that more clear?
I don't even know if it's possible with whatever they use for this, but I feel like taking the names of cities off the map would clutter less.
Okay,
Make it a little bit easier to see.
so maybe we don't need to see quite as much detail. And yeah, in Tableau it's like, yeah, you can, it just does what it
This
does.
is satisfied.
Oh, this is what? Satisfy. Okay. So Satisfy, then I have no idea because I haven't played with that enough. That's a great question. See, and then there comes the great question. And this is something that we're going to deal with throughout the course of the semester, but we're going to focus on. You have the picture in your head, and I talked to a couple of you about this. You have this picture, and you're like, I know what I want to do. But the tool that I have in front of me isn't letting me do it. Right? And that's one of the things about great visualizations, right? So Tableau is going to be great to do a lot of things. SAS Viya is going to be a lot more visually appealing than you're going to see Enterprise Miner and SPSS. But if you have a picture and you know what you want to do, a lot of visualization, you'll actually see people go out into like an Adobe type of environment and create their visualization as a true visualization. That's not going to be something we're going to focus on here, but if there's something that you know you want to do, make a note of it, let's talk about it, let's see if we can either figure out how to make it happen in the software we have, or again, I talked to a couple of you, and it was like, you know, Excel actually gave me the visualization that I want. Right? Tableau's great, but it wouldn't do this, and this is what I want to do, and I know I can make Excel do it. And that's okay too. Okay, so really we're trying to figure out what visualization is going to communicate the information the best, and then finding a tool that will help us do that. All right, let's see what else. Scatter plot, charged by the number of minutes. Feeling pretty comfortable about that one. Scatter plot of selected measures. Good that it's a scatter plot, a little less informative, right? So trying to make sure that you have a good table or a good title. And again, not necessarily for this assignment. You don't have to, if you have your stuff done, don't go back and just do it just to get titles. Okay? But in the future, as we're doing things, make sure we have good titles. We have our labels or axes labeled, so that's good. So customer distribution by state. So how is this ordered? Yeah, so we got frequency, right? So we've got largest to smallest, which was one of our Gestalt principles that we talked about. So the states aren't in any order, and that's okay. We've got churn 0 and churn 1. What does churn 0 mean? Churn 0 is false. What does false mean? They stayed with this. So as we start to do visualizations that we're going to present in like final reports, churn 0, 1, probably not the way we want to go, right? We want to make it where somebody looking at this and isn't as familiar with our data, it's very clear what's happening. And what do you think this pink's all about?
I kind of like it. Yeah.
Okay, so there comes the next question. Do you like having pink versus a white background?
I feel like it gives the graph a nice Florida vibe.
That's Florida. And a little sunset in the water.
Yeah.
I gotcha.
Geo orange and pink is very Florida vibe.
I mean, I think it's still. I don't think it's sunset on an ocean.
Okay. I'm not for it or against it. I was just curious what you thought were.
Like this one.
It's like, no, let me tell you.
Hold on. Can I explain or try to explain it? Or do you want to let?
Go for it. Go for it. So what are you thinking? Why is this the one you picked?
Well, you know, it looks really basic. Maybe it is, but so it's like using the web node node on the SPSS. And so I thought it was interesting. Again, I don't think it looks that great, but to me it was the most interesting graph that I was able to come up with, because it basically shows the relationship between like two categorical variables, in the sense that like the darker lines mean that like there's a stronger relationship like within the data. So for instance here, like the strongest relationship is that customers do not have an international plan or a female plan. Like that's what occurs the most. So, like the business question would be like, are customers buying both, or one or the other? And that's how you should see it.
And so, this was great. Right? Like, yes, it may not be the most visually appealing, but as far as informative, this is awesome because how many of you guys have been wanting to do correlations between categorical variables? Right? You're like, I know there's a relationship. I'm like, it's not really a correlation, or at least a correlation that we deal with. You know, so this is like the perfect way to represent a relationship without it having to be a straight up correlation. Okay, so that was a great graph. Okay. Again, probably not a visualization you would show someone necessarily, but at the same time, you almost could.
Yeah, I think you just want to make it look a little more geeky.
Not SPSS-ish.
Yeah.
Right, but the idea behind it, you can turn into a visualization on a slide, you know, with big voicemail, big node, yeah. All right, so I'm loving this right here. What is that? Right, but this is perfect, right? Because it's the same illustration of right here. I don't know what's going on because I've got Alaska and Hawaii. But when you take Alaska and Hawaii out, you at least now see all the dots on the different states, and it's not just a blob. right? So knowing when to have Alaska and Hawaii, when not to. When to zoom in on the Northeast. If something interesting is happening there, even if you've got data out here, you can make multiple graphs to show what's happening. Right, so here we're talking the size of a circle is the frequency again. Which would probably benefit from a little bit more of a title, which we've been talking about. I'm seeing a lot of, ooh, so what's this one? Is this bio? Tableau? I'm seeing a lot of Tableau here.
Yeah, we know it.
And it's pretty neat. Right, so nice. So total charge, this is your count of charge total. So this is your frequency. And this is, might be nice to have an x-axis. Right, but it's nice we can kind of tell what's happening here with the total charge. Another Alaska-Hawaii issue.
Would it be nice to filter and show the top 5 or 10 problematic states?
Absolutely. That's definitely a way to do it. Right, so you can do, like if you know exactly what your question is, and you're interested in, well, let's see the top 10, the top 5, where we can really start to look. Then you can just like exemplify, so instead of having to have degrees of red, you may just have 5 red states, or 5 blue states, or 5 purple states, whatever. So I like that somebody, like the default I think is blue, somebody here made it red. Let's see some change. We love the circles. Lots of circles. Circles for frequency. Right? And so here, well, I mean, what is your big story that we're hearing here? So this is the frequency of state, the frequency of, do you know what it is?
I guess it's how many times this, well, I guess how many customers have a phone number as that state.
Okay, so this is really just a frequency of how many people are in the state, right? So this is actually great. So it's really showing you that you're really distributed throughout the U.S. Right? So those area codes or those customers are very well distributed all throughout the U.S. There isn't really, California's teeny tiny, but everybody else maybe a little smaller in Iowa. Right? For the most part, the circles are fairly similar. So we've got the average churn, so we're looking at if you churn versus not churned. So again, we've got true and false, and if we're starting to do the visualization, true and false works great. Ones and zeros are essential when we're going to try and do our data mining and our modeling. But when it comes to visualizations, you could actually change that churn variable to be left company or stayed with company. Right? You control your data. You could rename your data to make your visualizations more informative. So we've got average, cust, serve. Maybe if we could, and I don't know if we can, so I'm just throwing the maybes out there, right? Maybe stretch this out a little bit so we could actually figure out what av, cust, serve might actually be.
It's interesting to me that there's essentially no real difference in charges between the customers that left and those that stayed.
And that's actually, I'm hoping to see, and I haven't seen it yet because you guys have been a little more with the visuals, right? Did you use the average? Did you use the sums? Like, what metric did you use? Right. You guys had most of you guys had Dr. Wang last semester, so that you kind of stole some of my thunder on this part. Right. But what metric do you use as you're making your assumptions? Because you're going to get 2 totally different stories if you look at the average versus if you look at the total. Oh, we clustered.
Yeah, so I guess kind of like, well, I thought this one was most interesting, not necessarily to show to people, like for like in a business presentation, but it helps me kind of visualize what things are connected and like grouped together.
Mm-hmm.
And so like for me, the most relevant was the account length is linked to evening calls and international calls.
Oh, that's a fun information. And I like that, like, so here the calls are over here, but evening calls are up here, but evening charge and minutes are down here. And sometimes the calls are connected, and sometimes, like here, it's all about the day. So that's pretty interesting. And we'll do clustering in about 4 weeks. Get to the season 1.
As far as enterprise planning.
That was the best I could do with that one. Perfect. All right, so here, so now I've got a day-night combo. All right, so we're both looking, we're looking at day charges on the left, night charges on the right. They're on the same scale, so that's good. By state, what's one thing that you notice from this? And it's anonymous, so I can pick on anonymous.
Leave the W in. Yeah.
So right there, we forgot to do our data cleaning. Right, so that WN, that Coast Guard, excuse me, the Coast Guard code, left the data cleaner, or left that in. Now, if you're using your visualization as an exploratory thing to find things like this, it's perfect. You're like, something looks a little weird. I need to go back and look at my data and figure out what that is. That's great. All right, let's look at a couple more. That's just informative, but that's the last one.
I think some are not ordered.
Oh, do I need to do some more? There are more. And so yeah, so informative, interesting when it comes down here. Some of our customers we kind of have this normal distribution of how long customers stay. And then we can start to decide, is that a good thing or not a good thing? Right? Here it looks like we're keeping people for about 100 units, whatever those units are. And then we're gradually starting to lose them. So how do we keep that, or at least shift it higher? So we got customer service calls by count length, sized by frequency. That's a lot going on there. So customer service calls.
Basically, I'm trying to see if there's any correlation instead of scatter plot.
Uh-huh.
Just thought more details in case there's a correlation, but there's no correlation, so we don't have to do.
So yeah, so really no relationship, which is great. Same thing here though. You got that wonderful little negative value way out here. So it's like, ooh, gotta go fix that one, fix this guy. Girl, dot, person, number. I always default to the word guy, and I always feel really bad about it. And then here we're looking at charge total. Right, so nice kind of seeing how our charges are distributed, and that's pretty great. Do we like how specific these values are? $74.18.4. A little weird. Hard to change in Enterprise Minor. Yes, it is. Right. But so something that, like, as we, like, if we were going to do this, this may be something that I play in SAS Enterprise Minor and I kind of see what's going on. But if I'm actually going to present this, I go to Tableau or I go to Excel or I make something that has like the graph the way that I want it to look. So a lot of what I wanted you guys to do is, first of all, thank you for participating. A lot of what I wanted you to do is just kind of see what was happening, see what you could do. Right? So I use a lot of these visualizations, and Will made a perfect point. It's like, I wouldn't necessarily show this to someone, but it's great insight, and now I know where to go with it. Right? Kind of the same thing here, right? I wouldn't present this, but I check it, make sure everything looks good, and it's a lot easier to visually check than it is to follow some of our, just like look through raw data. So how was that? Worth it? So a little bit of show and tell, a little bit of thoughts if you want to tweak your assignment. Don't forget to turn in your assignment tonight at midnight. Questions, comments? Visualization. So as we go throughout the semester, one of the things I'm going to try to incorporate a little bit better is what would be a good visualization to represent these results. Okay, so in some cases, the software is going to provide the visualization for us. In some cases, it won't as much. So we're hitting multiple linear regression today. So what do you think would be the best visualization to show some of these relationships? So like, let's say that we're trying to see if evening minutes and evening whatever can predict evening charge. Right. What would be a good way to see how the variables are related to one another? Scatter plots. Right? Scatter plots really, as we're dealing with continuous variables that we're trying to estimate, scatter plots really are a good go-to visualization. Okay. Once we have predicted values, then we can potentially make a bar chart of our predicted values to see how the distribution looks. Okay, the scatter plots are a really great way visually just to kind of do what we're going to do today. So I have the idea of let's create the churn story. I don't really remember what I was going to do with this. The idea kind of here was you're starting to have this story in mind, right? What do we know about these customers? And we've kind of talked with this through the visualization. Right? We're looking at sums. Did anybody actually calculate the percent of churn customers versus non-churn customers in your data set? Right? Was there more churn or more stay with the company? There's much more stay with the company, right? It was like a 20-80-ish, right? 15-85 or something, right? So it's a 20-80%. So how does that play into your mind as we're going to go forward? Okay. I really just don't have the timing for this. We'll move that slide a little later. So what I want to get into for a little bit is some of the linear regression and some of kind of the business understanding. What are we going to try to do? So we're going to stick with, I'm sticking with the churn data set. So we're sticking with the churn data set for the next 2 weeks. So assignment 3 is going to be a 2-week assignment. It's going to combine linear and logistic regression together. Okay, so instead of having to do one assignment on linear and one assignment on logistic, the idea here is you've looked at your data prep in assignment 1, you've explored your data, you've fixed your data, you've cleaned your data in assignment 2. For assignment 3, now we're actually going to model our data. And we're going to model it using estimation and classification techniques. Okay? So today we're going to kind of understand, and my question, as simple as it is, in our data sets, do we actually have the day charge per minute? I don't think we have that one, right? So if we go back, right? So we have the day minutes. Oh, we do. We have the day minutes. We have the day call. We have the day charge. That's like the total day charge. But we don't actually have the charge per minute, right? So way back in the day, that's actually kind of how plans worked. It was this many cents per minute for a daytime call, and this many minutes or cents per minute for an evening call. A lot of the times you got night calls for free. That was a big marketing thing there, right? Or it was this much for a nighttime call. It was this much for an international call. Well, we don't actually have that piece of information. So could we create it based on the information that we do have? Okay. So that's what we're going to look at, and I know it's kind of simplistic, but just kind of to understand what's going on. Like I said, these first kind of weeks are just getting you into the idea of what we're trying to figure out. So our other question that we're going to answer is, what's the international charge per minute? Is there a difference between day charge and international charge? And then does that charge change if you're enrolled in an international plan? Like, to me, that was a big question. Well, if I'm going to enroll in this plan, the whole reason I'm enrolling in the plan is so that I get probably cheaper international calls. So I'm not saying that I had these slides from last semester, but maybe I had these slides from last semester. I changed them a little bit. I just left this as a reminder for you. So step 2 was our data understanding phase. Hopefully by now we understand our data pretty well. Step 3, we're going into the data preparation phase. And so we're prepping our data, we've cleaned our data. So now I have a new data set called churn clean. So instead of churn dirty, now we have churn clean. So for your assignment, you're welcome to stick with your churn dirty set that you have cleaned on your own, or you're welcome to use the churn clean data set. Either one, doesn't matter. So we've kind of understood our data, we've prepped our data. For this point in time, we're going to say that our data is going to be prepped and clean and we're going to be happy with how it is. In a couple of weeks, we'll talk about a couple of different other things that we can do to prep it, but for now, we're going to say linear regression, we're going to leave it how it is. So then we're going to get into the modeling phase. The first part of the modeling phase is going to be variable selection. And really, without calling it that, we've already done this. We did this last semester, right? When we started doing our multiple regression, we tried to figure out which variables did we want to keep in our model, which variables did we get rid of in our model, right? We talked about the idea of multicollinearity. Okay. Not as important this semester, but we still want to keep it in mind. For us, we're going to have to worry about the idea of overfitting. Okay, so our goal this semester, when we're doing regression, is to be able to predict what's going to happen. Right, so we've talked about overfitting a little bit in the first week. Right, somebody want to tell me how you would explain overfitting?
When you change your data, or your output, so it matches what you think it should be, or what results you expect. Remember you showed us a graph, and there's one way that the relationship was, but then you changed the graph, the points in the graph, so it matched a better curve, or you changed the line to match the way the points were on the graph.
A model which
Say the
model which closely follows the variables instead of the trend.
Yeah.
So this goes with each variable rather than going to the trend.
What if we had height as one of the variables which happens to be there in the data set, where we are trying to predict if customers are purchasing, and then the model says that tall people are all buying, so so the model starts to account for that variable.
Yes and no. Yeah, yes and no. Because that's kind of the idea, and that's why you have to keep. That's more of a reason for multiple models, continuous model update, as opposed to overfitting. Because you can have a good model that doesn't overfit, but it models so well that eventually it'll take other variables into account, and so you need an updated model to make sure that you're actually capturing the things that you want to capture. So I kind of like the way that Harry put it, right? So model follows it, just following, I use data points instead of variables, right? So it's following the data points and not necessarily the trends. Right, so I think Courtney was kind of the picture that I drew. Right, kind of something like that. And so we like the idea of trends. Yay, that's the basic idea. But the overfitting piece is when I kind of connect the dots. I mean, I can make a function that does this, right? It would be a, a 7th degree polynomial. Okay? I could make this happen, and I would get this data really, really accurate. I could explain a lot with a 7th degree polynomial. Sorry, I'll drop some algebra there. But I wouldn't necessarily have a trend. So if I picked a new variable, and here was my new variable, instead of saying, oh yeah, let's estimate it here, we're going to say, let's estimate it here. It's a big difference. Okay, so the whole idea, and so with the dimension reduction, one of the big things we're going to try is we have a lot of variables. When we're trying to make predictions, do we want to have a lot of variables? So a lot of data is a good thing. Right? More data will often lead you to better predictions. But when you have too many variables, Now you have the collection issue. Now you have the potential of errors. Now you have to figure out how to model this. As you start to try to explain this and use it practically. If you have too many variables, this gets a little crazy. You've also got the computation time. If you have a lot of data, you've got a complex model, the computation time is going to go up. So ultimately, we want to try to reduce the number of dimensions, the number of variables that we have. However, we want to keep as much information as we can. There's a lot of different ways that we can go about doing this dimension reduction idea. We'll talk about it over the next several weeks. So one of the ways that we can do it is basic just domain knowledge, right? If a variable doesn't make sense, why would you put it in your model? So if I'm trying to predict a student's GPA, how tall they are is probably not an important variable. Assuming that we have, it could be an important variable if your age range is from 2-year-olds to 30-year-olds, then height could play a factor. But really what you're looking at is age, right? So thinking about just domain knowledge, if it doesn't make sense, don't put it in your model. Correlated variables, and this is where the multi-collinearity piece comes in. Here, you can just eliminate one or the other. Now that we're trying to do prediction, you don't actually have to eliminate the multi-collinearity, but you want to at least condense it, right? So if you have ACT and SAT, I'm picking on GPA for some reason today, right? If you have ACT and SAT, they're both highly correlated. Right? They're both a test of intelligence. Okay. But instead of having an ACT variable and an SAT variable, maybe you have an average, and I use intelligence loosely, right? But an average test, an average intelligence value. Add the two together and come up with an average. Maybe that is the variable that you want to use. So you're still containing all the information, but you're using a fewer number of variables. In regression, we can use regression models for dimension reduction. And this is something that goes kind of, students start to be like, are you serious? So you could, theoretically, as we go throughout the semester, and we're trying to do dimension reduction, you could do a linear regression, or regression equation first, to find the best variables for the model, and then once you have those best variables, then do a different type of model. Then do a decision tree, or then do a neural network. You can actually chain models together. Okay? So dimension reduction regression models have that dimension reduction capability. We've done this last semester, right? We tried the forward, the backward, the stepwise, a couple other options. These are the most common. So we'll do that. So for your assignment, you'll actually get to do all of these in different softwares. Some of the software actually have dimension reduction nodes or options built in. Right? So SAS/EM has something called a variable selection node. And it's going to run, and really what it does, loosely, is it's running a regression analysis behind the scenes and saying, these are the variables that I think are worth keeping in your model, and these are the variables that aren't. And at this point, it actually uses an adjusted R squared to talk about how much variability you can explain. Not our end goal, but for the variable selection process, how much variability is being explained by a variable is a good thing. For prediction, that I don't care anymore. But for variable selection, it's a good metric. The feature selection node in SPSS does something similar. These two nodes will use different techniques of how the software is deciding what they would recommend stays in the model or leaves the model. Because of that, if you use the feature selection in one model, it may say, you know what? Let's say you have 10 variables. This features or variable selection in SAS may say there's 2 variables I think are really important. These are what I use. You go to SPSS and it's like, you know what? There's actually 8. 8 that I think are viable candidates. Why don't you keep all these 8 and we'll see what happens later down the road. Okay? I'm not going to get into all of the math and stuff behind it. We're welcome to start to dig. A lot of it we just have to kind of dig into each node and see how it works. So the idea is that they exist, but you still have that common sense. Just because variable selection says don't use this variable, it's still just software. You still get to decide. It's like, but no, if you're telling me to use this variable, then I've got to use this variable too. Right? Just because of, again, that domain knowledge, what makes sense. So again, the whole idea kind of behind variable reduction is we're really just kind of trying to reduce the number of variables that we have to make our model more simplistic, more straightforward. The easiest model generally wins. So these are kind of how the variable selection nodes work. I will show you kind of what's happening. So this is SAS Enterprise Guide, SAS Enterprise Minor. So I'm teaching, so on Tuesdays and Thursdays, I teach basically the undergraduate of what I taught you guys last semester, and I use Enterprise Guide again. And so I say Enterprise Minor in that class all the time. And now I get here, and I'm like Enterprise Guide. So the SAS thing we're going to use, so Enterprise Minor. So what it'll actually do is it'll show you all of the variables, and then it'll say, you know what, reject these. Get rid of them. These are the ones that you shouldn't use. So for some of these, like the record ID, it's going to say, and then it'll give you like a reason, right? So here it has small r squares. So that's the reason it's saying to get rid of. One thing I noted on your assignment 1 that I just finished grading, so I asked, I won't say it's a trick question, but it was an interesting question. So in our churn data set, we have a customer, we have an ID value, right? It's not their phone number, right? Their phone number was a unique identifier, but then we also had like a customer ID that was a unique identifier. And one of the things that you had to do, right, you were trying to decide what type of variable is this? Is it categorical, qualitative? Is it continuous, quantitative? Some people said that ID was a numeric variable. Some people said it was a categorical variable. I had one person say, I don't really care because I'm never going to use it. I actually love that answer. Okay. So that was kind of a weird question because when it comes to record IDs, when it comes to customer IDs, when it comes to just a unique identifier that means nothing, right? You could make the assumption that it's nominal, that it's just a number that doesn't mean anything. You could make the assumption that it's ordinal, that there's probably some order to it, whether we know what it is or not, It's generally never, although it's made up of numbers, not really a numeric variable, because we're never going to do any type of math with it. In fact, we're never really going to do much of anything. So unless there's some really, really good reason, most of the time, anytime you see a record ID, you'll just automatically get rid of it. Should never show up in analysis. There's just, there's very, very rare cases where that would do it. So if you got that note, that's what that note means. So rejected there. Let's see what else we have. So other options that it'll show it, it'll say, sometimes if there's too many missing values for a variable, the variable selection will say like, too many missing values, we're going to kick that out. Yes.
Here's a question. So like on the churn set though, it's kind of nice to have the ID for like the distribution across the states. So you can see like, oh, we have this many customers in California, in Iowa. Or are we talking about something different?
I totally see where you're going. So I'm okay using the ID as far as like a count of customers, so like a frequency of customers. Right. That's totally fine. But you just won't use it, right, you won't use it as a model.
Right, okay.
Yeah. Yeah, so for descriptive purposes, if that's something you're going to use to like count frequencies and things like that, absolutely. But as far as modeling, like you're never going to put ID as one of the variables in a logistics regression.
Okay.
Or a linear regression or a decision tree.
Right, so that makes sense.
Oh, we're going to break this on ID number this through this goes this way, and ID number this through this goes this way.
Right.
Unless it's something that is like, okay, this was customer number 1 that we ever served in our life. It's number 1, and now we're on customer 5,000. And so, oh, now we can see that customers 1 through 100 have this because they were our first customers.
Right.
And our new customers. But by then, you can probably have another variable that's like old and new customers, or times with company, or something like that, that would replace just the actual ID. But yeah, that totally makes sense. So thank you for that. Yes.
So how can ID be categorical? Because category is usually something which classifies, but for ID, like for every value, we can have only one. So we cannot actually say that it's a category under which something is going to be classified.
But it's not. So for me, so a numerical variable, a quantitative variable is going to be something that you do math on. So if it's something that you do math on, then it's a categorical variable, or then it's a quantitative, it's a continuous variable. For, like, let's say phone number. We'll come back to ID, right? So phone number, right? Everyone has a unique phone number, but it's not actually a numeric variable, it's a category. Now you only have one person per category, so it's not like you're necessarily going to be grouping them and creating, like your frequency of phone numbers is still just going to be 1. Right? Same thing goes with ID. So ID is going to be a classifier. We're going to use that to classify you as customer number 1 and customer number 2, as opposed to it's something that we can do math on. Does that help? Any other thing that you just, as we come across them, we'll talk about them. So again, so with our variable selection, things that we think of, if they have small R squares, it's not going to contribute much to any model. You might kick it out. If there's too many missing variables, or too many missing values, then it's like, you know what, there's not enough information in this variable to use it. Or sometimes if there's too many class levels, like phone number, right? That's the perfect example because like there's 3,333 in the term data sets, right? Because they're all unique. It's like, no, we can't do anything with this. It's useless. Let's get rid of it. So there's just some of the reasons that we might get rid of variables. Same thing, so it's just a different way to do it with this different node. We have to have a target variable, and again, it gets rid of things, too many missing values, too many class levels. It's just not going to contribute to a model. So we're going to play with these different softwares in the second half of class, which is why, but I just like to have some screenshots sometimes so you can kind of go back and kind of get the big picture. The one thing that we're working on, I'm going to be very transparent with you right now. So SAS VIA, SAS VIA. The main thing that we're looking with at SAS VIA right now is SAS Visual Analytics. SAS Visual Analytics is great. It shows us a lot of stuff. It's a wonderful way to get some quick information, be able to explain your models, compare your models. There's a lot of really great features. The one feature that it doesn't have really well yet, it does, we just haven't played with it yet, is some of the model cleaning, some of the stuff that I'm showing you right now. So, potentially at the end of the day today, I'm going to introduce you to an area that we do not have tutorials for, that you are welcome to play with, see what's what, as you start to explore. But we're in the process of building the tutorials to make all this work. We just got a data connection so that we can play between these two different pieces of the software. We just don't have the tutorials yet. So, full disclosure, you are my guinea pigs, but you're going to learn a lot as we kind of go through this. Let's go through this theory part real quick and we'll take a break. So we've got a business understanding. We forgot about it because we talked about it 20 minutes ago, right? But we're going to try and figure out, can we figure out the charge per minute? Right? We've got our data clean. We're going to try this feature selection, see which variables we actually need to play with. And then we can actually model. Okay. So linear regression, you're going to see this slide every time I introduce a new concept to you. This is one of my favorite slides. I've worked really hard to try. Oh my God. I've worked really hard to try to make this fairly consistent throughout the semesters. This is your key characteristics for multiple linear regression. Okay. We're going to have a target variable. We're going to know what our target variable is, and it's going to be continuous. So if we go down our path, is this a supervised or unsupervised? Supervised. And then do we have an estimation or a classification? All right, so we've got supervised, estimation task. Okay. So it's going to be model driven. When I say model driven, this means that we can make an equation. There's going to be a lot of the data mining methodologies that we go through that are not going to have an equation that goes with them. Okay, they're going to be data driven. This one in logistic regression is going to be model driven, so we can make an equation. Our goal here is we're going to predict target values and other data where we have predictor values but not target values. So our goal is trying to predict something new. So big overview, right? Given a set of predictor variables with an identified numerical target variable, we are looking for the best combination of predictor variables in our training set that's going to predict what's going to happen in our validation data set. Okay, so we're going to use different selection methods to help us determine a best set of predictors, right? Not the best, but a best set of predictors. And then we're going to use fit statistics to determine a best model. It's very similar to what we did last semester, but the difference is going to be the fit statistics that we use are going to change a little bit. Okay, so when we're talking about our interpretations, what do we need to talk about? Okay, we need to talk about the conditions of the best model. We're going to talk about the equation of the best model. And potentially we're going to do an explanation of our coefficients. Okay, so as far as the modeling process, as far as the interpretation process goes, it's very similar to what we did last semester. The difference, like I said, is mostly going to be in, right here, the fit statistics that we're going to use. And I'll introduce those in just a few minutes. So, really quickly, this is exactly what we did last semester, so just a very brief overview. We have our model. We talked about the residuals, where we're comparing our actual value from our predicted value. We had the hypothesis that we were testing. Right, so we were trying to look at, is there a linear relationship or not? So this was last semester. We had a test statistic that we used. We had some assumptions that we checked. Again, because we really cared about, does our model fit? And how are we explaining? Right, so we wanted to make sure that we have these assumptions met. We're kind of looking at some scatter plots to tell that. That was what we did last semester. Just very quick overview. For what I'm going to do today, because I can't just do your assignment for you as much as you'd like that, we're going to use the Boston housing data set. There's actually, if you get on Blackboard, I have the article that actually this came from. It's old, but it's kind of interesting. It's also one of the examples in your book. And so what we basically have here is we're trying to predict the median value of home or of owner-occupied homes in thousands of dollars. We're going to try to predict, given all this information in the Boston area, how much does this house cost. So if it's an area where there's high crime rate or low crime rate, then this is actually the crime rate, so the percentage of crime. Looking at the percentage of residential land that's zoned for big houses. Okay. Looking at pollution, nitrous oxide. Looking at how many rooms are in the house. Looking at, this is actually a categorical variable of does it bound the Charles River or not, right? You have a nice river view. Pupil to teacher ratio in the town. Right, so just all these different values that you're looking at to see, can we predict the median value of the homes in the area? So we can do this. Right, so this should look hopefully very familiar. And again, this is just a recap, hopefully it makes sense. If you have questions, stop me. So our review of multiple linear regression with our goal being explanation, we're trying to explain what's happening. I ran my model. I came up with an equation that LSTAT, if we go back, let's see what LSTAT stood for. The percentage of the lower status of the population, so lower status. So we start out with negative 1.4, we subtract 0.6 for our LSTAT, and then we add 5.1 times the number of rooms. Okay. So we have 5.1 is interpreted so that for each additional room in the house, we're going to increase our estimate by 5.1, or about $5,000. We've got an adjusted R squared of about 63%, so not the best, but not the worst. We also have this other number that we hadn't really looked at before. 5.5 is root mean squared error. So last semester, when we were trying to see explanation, we were focused on our adjusted R squared. How much of our variability will we explain? This semester, when we're talking about estimation tasks, we're going to focus on our root mean squared error. Does anybody know what that is? Brilliant, and I can tell you whatever I want to do. Okay, so our root mean squared error, or you can Google it, you'll find the same thing. The idea behind this is basically we're looking at the deviation between our actual and our predicted prices. So we're basically saying how far off are our predictions. You can get real technical, you can look at the equation that goes with it, but basically that's what we're saying.
So they're kind of like residual.
You use the residuals to get it, yes.
Oh.
The residuals are part of the calculation.
So if you're graphing it and you've got all your data points plotted and then you have your line, is that the difference between a point and a line? Or is that
So the difference between the point and the line is the residual. And so this is going to be roughly an average deviation of all of those points.
so if you square it that way it's negative?
Exactly. So you've got, because your residual is you're going to overestimate, you're going to underestimate. Right? So we're going to wind up doing some squares. Then we're taking the square root of it, so that way we get back into the same unit as what we're talking about, as what our dependent variable, our target variable is in. So that's kind of the math behind it. The idea is going to be kind of what this means. So this we're saying 5.5, but we're talking about we're in thousands of dollars. So what this is saying is the average deviation is about $5,500. That's how off we are. Okay, so on average, given our model, we're going to be off by about $5,500. And maybe that's great. Maybe that's not okay. This is a very subjective number. Okay? Yes.
So it's not like the just our square, where it's like like oh, if it's in this range, it's good or bad.
Right.
This is like it just depends on.
It totally depends.
Okay.
Since squared is plus minus, you can be off that
Yes.
far in either direction.
Yes, absolutely. Right. So we're either going to over or underestimate by about $5,500. Okay. So this number will let you compare multiple models. So if I compare, so this I just did, I don't remember what I did, right? But I came up with this model. So maybe I did backwards regression, I did stepwise regression, I did forward regression. So I have several different models. I can compare the root mean squared between models using the same data. Okay. What I can't do is compare this value to different data sets. Okay, so like what you're saying. If I know my adjusted R squared goes between 0 and 100%. Once I get up to especially the 70s, the 80s, and I'm like, yeah, I'm explaining a lot of variability. Here, 5.5, right? This could have been, had we actually just changed the data, and instead of making it data number in thousands, we actually wrote out the thousands, then this root mean square would have actually been 5,540. Right? That's a huge difference than 5.5. Okay. So it's not about the value itself, it's about comparing the value amongst potential candidate models. So there is no wonderful if it's 0.7 for a correlation, it's strong. So there's none of that. Okay, so it's really just used as a comparison tool between models on the same data set. So let's see. We have a regression equation. We can plug values in to make determinations, see the different residuals. I think now is the time to take a break. Okay. So that was kind of a recap of linear regression from last time. A little bit of a foresight into what we're going to do this time. We'll take a break. We'll do our multiple linear regression. Everybody ready? Coming back? Excellent. Okay. So, real quick, the last big push that I make for this is really distinguishing between the statistical approach and the data mining approach. So we've already talked about this a little bit, but just so you see it in black and white. Statistical approach is the exploratory, is the descriptive modeling. It's what can we tell? What's actually happening? The data mining approach, really all our focus is on prediction. If you give me new data points, if I plug them into my model, how well do I predict what's happening? Okay. So again, statistical approach, our main goal is just finding the best model to describe. Our main goal here is finding the best model to predict. Statistical approach, the adjusted R-squared, that's like our bread and butter. That's where we go. We try to explain the amount of variability happening. Over here with our data mining, our fit statistic, the main one that I like to use is the root mean squared error. You can also use the mean average error or the average squared error. They're very similar. Big difference in why I like the root mean squared error is just because it kind of gets it back into our original unit. I have a slide later that kind of details all the differences between these different fit statistics. There are a lot of other fit statistics. The other reason I really like the root mean squared error is because for all of the different data mining methodologies we're going to do throughout the semester, it always provides a root mean squared error. There's going to be some different errors that are more specific to the different methodologies, but as far as one that's consistent that we can use to compare all of our different models, the root mean squared error works out really well. So again, we talked about, yes?
So the root mean square is low, and even if the R square is also low, it doesn't matter.
For our purposes now, it doesn't matter. So you may have a model, it generally doesn't happen, but you may have a model that doesn't explain things well at all, but is really great at predicting. And so for our purposes now, as long as it's great at predicting, I'm not going to focus on the explanation. I'm going to focus on how well it predicts. So as we start to do kind of that dimension reduction thing, one of the things we're going to learn is called the principal components analysis. And what it does is it basically might take several different variables and smash them into one. So then it's really hard to interpret that one variable. However, that one variable, with the linear combination of these four other variables put together, predicts really well. So explaining is going to be hard. Our adjusted R-squared is going to go down a little bit, but our predictive ability is going to go up. And so that's what we're going to care about. So you can have a lower adjusted R-squared, but a higher root mean squared, and then for us, for the data mining purpose, we would take the higher root mean squared error, or in this case, the lower root mean squared error. Right, so lower errors better. Yes, lower errors better. Right? We want to have fewer errors. So when we're comparing things, the one with the lowest errors is better.
What does it mean when a model is good at predicting but not explaining?
So it's one of those that I can predict what's going to happen. You give me new data. I can put it through my model, and I can predict what's going to happen next. However, it's a little bit more difficult for me to explain things and explain what's happening, right? So for the explanatory, I really care about the coefficients, right? I want a coefficient that I can talk to you and say, you add one bedroom to the house, then the price is going to go up by $5,000. Right, so that's something I can explain. But when I'm trying to predict, I may take several different variables and kind of put them all together, and I may not be talking so much about explaining what's happening, but I can predict more accurately what's going to happen with a new house.
So is explaining, is it mathematical or just like being able to like human terms, just be able to explain why this changed?
More than human terms, right? So it's really just about what's your goal, right? So is your goal to take your existing data set and find the best model that fits that explains what's happening. So in that case, the concept of making that 7th degree polynomial, if that explains the data better than a solid line, a straight line, then that's an okay thing to do. Because I'm trying to increase my adjusted R squared. I'm trying to find the best model that explains what's happening with the data that I have. That's the explanation idea. The prediction idea is I'm bringing in new data, and I want a model that's going to generalize the best. So if I bring in a new data point, and I know these 3 things about it, can I predict this dependent, this target variable, the best and most accurately that I can? So that's kind of the idea. It's like, what's your goal? Is it really just to explain what's happening with the data you have, or is it to make predictions in the future? So again, you can do both things well, but just the focus on the metric that you look at. So the underlying linear regression, that doesn't change. The math doesn't change, the least squares doesn't change, how you're getting the residuals doesn't change. None of that changes. The only thing that changes is just the focus. Am I trying to explain what I have, or is my goal really to predict something? Yes.
Just to add to that, there's the mean square error of the test data, not the analysis data. So that's what really shows how good a model is. Right?
Yes, yes, absolutely. So the things that we'll start to compare is we'll have, so to hopefully prevent that overfitting, we're going to have our training set and we're going to have our validation or testing data set. And so the 2 things we'll compare is we'll look at the root mean squared error from our training data set, and we'll look at the root mean squared error from our validation data set. And if they're pretty close, then we can assume that that overfitting isn't happening, right? But if we have a really small root mean squared error for our training data set and a much larger error for our validation data set, then we've probably overtrained our model, and bringing in new data isn't working out well. So then once we have, okay, there's no overfitting, we're good. Then we've got the validation root mean squared error for forward, backward, stepwise. And now we'll compare across the models to see which one has the smallest error. And that's going to be the model that we choose. Does that make sense? So it's kind of the big picture of how things are going to go. So, again, kind of the variable selection methods we went over before. All right, we've got forward. The idea is our complexity is going to increase. We're going to start with just one variable and add more variables. Our backward, we have all of our variables. We start taking things out. And then the stepwise, we kind of do a combination, right? We start with one, and then we add variables. But we can also take variables out, and kind of the idea. I have some slides kind of detailing forward, backward, stepwise. Are you guys comfortable with that? So some examples of linear regression. Again, one of the things I try to do always as I introduce a new topic is give you some key examples. The city of Boston wants to predict the median house price in new census tracts based on historical housing information. So that's what we're going to do. A Toyota dealership needs to be able to predict the price that dealers will get for a used car. So we're trying to predict, we're trying to estimate. We got a software wants to predict the spending amount that a purchasing customer will yield. So we have a customer, we're trying to predict how much that customer is going to buy. We have a consulting firm is predicting airline fares based on flight patterns. So all of these things we can use linear regression for. Anytime we're trying to estimate a continuous variable, linear regression is something that we can try. Do we see the slide? Dustin is the outlier. Alright, so software. So let's play with some software. So I've got slides that kind of show things, but I feel like it's more fun to kind of walk through it. We've got visual analytics. So SAS via visual analytics is going to show us one way to do linear regression. We've got, this is the model flow. I am so sorry, I don't think I've used that word, apparently. So when I ask for your model flow, this is what I'm looking for, right? The model that you built that kind of shows what's happening. So this is your model flow in SAS Enterprise Miner. And the reason I have this red arrow right here is this selection method. So this is on that left-hand side. This is where you change the selection method to be forward, backward, or stepwise. We'll do a little SPSS. Hey, why not? And for SPSS, you actually have to have a new node for every single one of these things you do. There's two ways to get to linear regression in SPSS. The top one you can do, it's actually a linear regression. The second one says GenLin. So this node right here, this is just your, that guy. Looks like blue is a bad color to use. Green. Or this GenLin, both of those will give you linear regression equations. We have tutorials for all of these. This is your fun homework to play with. I don't expect you to learn all three of these. Okay, so your homework is going to focus on the SAS Viya, the visual analytics, and then your choose your own adventure. Your options are to pick one other software to kind of duplicate your results. You also have the option of critiquing our videos and tutorials. Okay, that's fun too. Or you have the option of, I think you have the option of going and like researching the telecom industry and adding more of a detailed business understanding and deployment option. So depending on what you want to do, which area of the data mining process you want to focus on, you can do that. Alright, let's just do this. So I want to get into, the first thing I'm going to do, let's start with SAS Viya. You guys will remember SAS Viya, so you have either link or it's wcob viya.uark.edu. Your user ID, and password. You can see I've started playing with a few more things. So now I've got a few more options here. I think today what I'm going to do is let's start back with our churn data set. Right? Because that was our business understanding. Our big initial question was, can we use linear regression to predict the minutes that we're charged, or how much we're charged per minute? So I'm going to go ahead and start a new report. Like I said, more tutorials and videos for this, but we'll do a little bit together. Obviously, I forgot to save my work. So. Alright, so remember we're going to pull in our data, so I'm going to go grab a data source. And then look at all these things where apparently I was playing with stuff late last night. Not that late. I'll go edit this out here. So again, you'll notice that people have been putting things where they're not supposed to.
I don't know what I'm doing.
So make sure to, and this is the learning process when it comes to SAS Viya. Obviously, look, you're not the only one there. You got a lot here. So what you want to make sure to do is, as you're saving your data sets, when you import your data, wherever my data comes from. How many data? I always forget that I don't save data on this. Try again. So whenever you're importing data, somewhere I have a data set. That's the science. Alright, so whenever you're importing data, don't forget that right here, this target destination, we've changed it so that it's not a default. So now you should have to fill this in, and when you fill this in, don't do the cache shared default, which is where everybody's going. Make sure to change it to the cast user with your name. So if you're saving data, make sure to save it with your name. I don't know. That's what you did the first time. It's not what you did the second time.
That's what I did.
Like I said, this has happened many, many times, so it's not a big deal. Not a big deal at all. It's just we just have to start to get a little messy. And I believe you did. 4 of the 5 times, that's what happened. Alright. So I'm going to use my churn. Oh, I don't want to use churn dirty. So this is different people's churn dirty. Yes.
Are we importing an H in the queue? Or
No.
is that just
That was just me showing you stuff. If you did, that's fine. That's cool. You're going to use it later. So it'll be fine. It's just not what we're doing right now. Yeah.
churn clean?
So turn clean, I think is actually what we're going to do right now. Okay. And I'm going to steal somebody's turn clean. Which is awesome. See, you put it in the public file and I just steal it and open it up. Okay, so I'm going to open up churn clean. So whoever this is that put it in the public file, we'll say thank you to them. So we're going to do the churn clean. And you're welcome to open up your churn clean set, like whatever you've been playing with. I'm just going to do the churn clean data set, so we're good to go. I'm going to click OK. So now everybody should have some data set to be used. Everybody good?
Fine. So in Excel, it says I have 2 distinct values. We're going to put it into 5 or something.
Because if you have any missing values,
Like for your tags, did you put that out of the
Oh, no, okay. So what I think it does
so if you have any missing values, it'll count as distinct values. So we can filter that out, so it's not indication. Yep. Yes, it'll say that there's 3 churn options because there's a missing value.
Oh, okay.
And that's totally fine. So, alright, we'll play the game real quick. We're just going to do it this way. So I'm going to data set. Thank you for your patience. I'm going to do churn clean. So what you will see in my churn clean data set is that at the very bottom, I have a blank cell for churn. So 3,333 has a blank cell for churn. Okay. So if you're using your data set, it's been a fun day, hasn't it? If you're using your data set and you did something to this, whether you replaced it with false, because you said, hey, I'm going to replace this with majority. Or if you're like, hey, we don't know what this is, so I just deleted this column. Or deleted this row. Any of those things are fine. Okay? I'm using this as a missing because I have a reason for doing it later. But so right now, so if you import my churn clean, you'll see that there are 3 options.
I don't need to blank all of my categories. Like I didn't, but I said it had
So for now, I do the churn clean one. If you want to follow along, and then we'll figure it out after class. Alright, so I'm going to save this on my desktop. I'm just going to go ahead and import it myself. So for me, because I can, I'm going to leave it in the public file so that way everybody can see it. Okay, so this is the fun thing that just happened, right? So there's a churn clean data set. Someone else has already imported it, right? Because that's what we opened. And I said, I'm going to import it, and I'm going to put my name on it, so that way I can tell my students, hey, pick the one with my name. And now it says, the table already exists. So if I import, so I can replace the file, and I'm going to because I'm the instructor. Right, but when I replace the file, then whoever was like, I know I saved this here, I know who it is, I'll send them an email, it's okay. But whoever did this is going to be like, but I saved this, like where is it, what's happening? And so this is one of the reasons not to save stuff in the public file, because if people use the same name, they can just save right over any work you've done. Okay. So like I said, I'm going to do it just because I'm going to email the person who is in the Saturday class. I pointed thinking that I have a video in this class and I don't, so it's just one of those days. Alright, so I'm going to import the item. Alright, successfully imported it, life is good. The churn clean is here. So if something's going wrong with yours, you can just import mine, and that's the one I'm going to use and go off of today. So yeah, so now I have no idea why you're getting the 3, because I just imported churn clean, and I've got 2. So now I got nothing. Okay. You got 4?
Not from yours, from mine, but all the variables are the same.
So, things that are different. If you have 4, when you were cleaning your data in Excel, fun story. How do you guys, so it says true, 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 false, 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 and there was like a yes and a no. Right? And you went and you changed it to true, and you went and you changed it to false. Right, data cleaning? Okay. When you did that, was it lowercase or was it uppercase? It was all caps. So although although Excel is showing you the word true, it really used a 1. And although you said false, it really used a 0. So when you actually go, and I had to figure this out the hard way, it's the only reason I know. Right? So if you're seeing 4, then that's one of the things. So yeah, so the best way to do is like take a true that's already there, and just copy and paste over it, and then take a false that's already there, and copy and paste over it. Yes. Okay, so things we're looking at. We've got to make sure, so we just imported our data. Let's make sure that everything's good to go. Churn's a category, international plan's a category. If you've got 4, if you've got 3 different churn things, we'll make it work, don't worry. We've got 3.5, or 3,000 rows of data, phone numbers. This is something we're not going to use. We're just going to leave it hanging out. We've got our voicemail plan. So these are all categorical variables. We scroll down, we've got account length, we've got area code. Somebody tell me about area code. Is it a categorical or is it a quantitative variable? Area code's really categorical, okay? Because we're just looking at them in terms of categories, right? This is the 918. This is the 501. So I'm actually going to use little drop-down arrows. I like area code. That's a fine name for it, but I'm going to change it from a measure to a category. And it's going to pop up here and say, look, 3 area codes. Yes.
I just changed the data source from mine to the churn thing which you uploaded, but still it shows churn as 3.
Yeah, same.
Seriously?
And I don't have the churn dummy or the charge total on the, because I just trace on Blackboard.
And this is why we love interactive workshops. All right. The easiest way that I can think to do this, to be perfectly honest with you.
Close it out.
Yes, that was actually it. So if you're having issues, and the only reason I say that is because I'm wondering about the timing of uploading. So I'm going to see what happens. So I'm going to go do none of those things. So I'm going to exit out of this. Really? I'll do news. Yes.
Do you know what an error called 412
You want to
means? Yeah, I know.
That's a blow.
We're gonna make this work. I told you this is a little troubleshooting. I really appreciate you guys going on this journey with me. All right. So, but here we kind of have one of the, if you want to, we'll do the data integrity issues. Didn't plan to have that conversation today, right? So the data integrity issues, we have to make sure that we're all working on that one version of the truth, right? So we have to make sure that if we're going to make these analyses, we're going to be talking with each other. All right, so I'm going to do like next. I don't want to save what I'm doing because it's messed up. So I'm just going to hit. It's messed up. So underneath my name, there's the 3 little dots. I'm going to just do new. I'm not going to save it because I don't like what I've done. And so now everything should be good. We should start fresh. So if you start from a fresh report, and again, if you like your data set, that's totally fine. Work with it. We're going to bring it in. It's going to be churn underscore clean. All right, so not the churn clean, but the churn underscore clean with EKB. That's me. So the EKB. Yeah. EKB, not keeper.
Did you change so that the missing sign was replaced?
No, I didn't.
Yeah, so there should be 3.
There should be 3. Yeah, so I don't know why mine didn't do 3. So we're about to find out. So we're bringing in the churn clean. So you got 3.
Yeah.
You guys got 3.
Yeah.
Things are good. 3. Everybody's happy with 3. I'm going to bring mine in. Now I've got 3. Yay! Okay, so everybody's got churn for 3.
Did you like edit the errors? The one that
Well, I thought I opened a new one, but who knows?
Okay.
So mine. So you don't have to. Like you can use yours.
That's fine.
Okay, but for me, I've got churn 3. I don't remember if I got. Okay, so I'm going to go ahead and I'm going to go back and I'm going to change area code and I'm going to make sure that area code is a category. Still got that ID. Really, there's nothing to do with ID because we can't just like delete variables like we could in the past. Right, so like when we import some stuff, we can like drop variables. This doesn't really give us an option to drop variables. We just have to know to ignore the ID and not use it.
You can hide it.
So if you right-click on it, you could hide it. Go Jacob. You'll notice that there's a frequency variable in here. And so that might actually hit what you were saying, right? We wouldn't use an ID necessarily, we would use this frequency idea, which would still get us the same information. All right. So we're there. We've got some stuff. We have some data. We're going to play. A couple of things that we want to try. Okay. Step 1, I actually, at the very beginning, at the very top, so we have our data, Now I want to add a new data item. So we've brought our data in. That's step 1. Bring data in. Step 2, check data and make sure it's how we want it. Okay, we did that. So no matter which software we're using, we have to bring the data in, and we have to check to make sure that it's set up the way we want it. Okay. The next thing that we're going to do is we're going to create a data partition. Okay. So if I was to, really tiny up here at the top, step 1, I'll take a screenshot of this. Bring data in. Step 2, verify data. Sure. Verify data types. Step 3, data partition. Reload data, so that's up. Data partition. So whether that's a node that we're bringing on the other softwares, in this case, we have a new data item that we're going to have to create. So click New Data Item, and there's going to be a partition at the very bottom. Have we done this yet? Okay. I didn't think so. Okay. So new partition, the name of the partition, we're just going to be really generic and call it partition. Okay. It's based on sampling, which is totally fine. We're going to use a simple random sampling method. We don't need to do anything fancy. I like a lot of the defaults. Here we're going to have 2 partitions, which is we're going to have a training and a validation data set. You could make 3, and then you would have a training and a testing. Okay. But for us, we're just going to stick with 2. So we talked about the fact that it was like a 60-40 split was kind of the default that I was going to use for this class. Again, you're welcome to modify that, but that's going to vary your numbers. Okay, so for me, I'm going to do 60% is going to be in my training data set. And then I'm going to click OK. So nothing crazy.
What is the random number seed?
So if you do a random number seed, then you can actually choose, like, start at whatever. Generally, the default you'll see is 1, 2, 3, 4, 5. So again, if you keep the default, you're good to go. If you change the random number seed to your favorite number, then your data, the sample of data that you pick, is going to be different than your neighbor's sample of data. So we'll click OK. And now we have a category variable that's a partition, and we'll use it later. All right. So again, we're still going back to our goal is to, can we predict the average charge from the information that we have? And for the sake of time, I'm going to skip the day minutes, and I'm going to go straight to the international charge. I'm going to follow up question with that. It's the same process. So let's see what we want to do. Let's go to objects. And here, when you guys played, you have your tables and your graphs and your charts. So for fun, maybe I want to do a correlation matrix. I would actually like a scatter plot. So I might drag a scatter plot over. And then the required roles have not been assigned, so let me figure out. I'm okay with kind of the default look, but now let's see, I want to do, let's do international calls, international charge, international minutes. Let's see what we do if we pick 3. Okay, so our big goal is, can we predict the charge per minute? So I'm going to see how these 3 things are related. So since I picked 3, we have international charge versus international calls, international minutes versus international calls, and international minutes versus the international charge. So I feel like we're probably going to be able to create a regression equation for this, right? Alright, so we've got this. And so up here at page 1, the little drop-down options, I'm going to rename the page and just call it visuals. call it scatter plots, you can call it whatever. And then I'm going to create a new page. Again, just trying to show you different features of the software as we go along. And so for this one, I'm going to have, again, my data sources out here. Everything's good to go. This time for my object, I'm happy with my visualizations. I don't need the control. And you don't have to close all these. I just am so we can see a picture of it. So we're going to go all the way down to the / visual statistics. And we have a linear regression option. We're just going to drag the linear regression into our big topic. It's like, look, we're going to show you some cool stuff. So now, obviously, the required roles haven't been assigned. So what is our response variable? Charge. We're going to try and predict international charge. And what different continuous effects are we going to use? The international stuff, right? So the international calls and the international minutes. See if we can predict the charge. And as you start doing this, things are starting to change over here. Are there any classification variables we want to use right now? So let's come back to the plan. So we do want to do the plan, but let's wait on that for a second. Okay. We're not going to worry about interaction effects. We have this partition ID. Remember we created a partition? So let's go ahead and go and add a partition ID. And there's only one option. So this is going to be our 60/40 partition. And so you'll notice things kind of start to change a little bit. So this is kind of interactive for us. We're not necessarily grouping it by anything, the frequencies, the weights, all of that's good. Okay. Really quickly, we now have a fun visual of what we're looking at. So we have our fit summary. So this is international minutes. That looks like that's very important. The international calls, not quite as important. Okay. So really, we could probably get rid of international calls and still get just as good of a choice. So this is something that isn't seen a lot. Up here at the top, can you guys see everything up here? Because I can make it bigger in this software. None of the other ones. So up here at the top, we have international charge. These are the options. These are the fit statistics we have that we can look at. So these are some that we're not going to use too much. If we were looking for the explanatory, we could look at the adjusted R squared. Right, you just click on it. It's like, ah, look, it's going to be perfect. Right, but we're expecting that. Okay. Same kind of thing here. You can look at the mean squared error. There's no error. Right, you can look at the root mean squared error, and oh, there's a little bit of fluctuation. 0.0029. Right, so less than a penny. Still. So we've got our fit statistics. We're kind of like, this is what's looking at. We've got our studentized residuals. There's everything. There's no pattern, so life is good here. We've got our predicted assessment. The predicted and the observed are right on top of each other. You can't even see the predicted average right here. So ideally, you'll start to see fluctuation between these two lines in most cases, and we will when we get to the Boston housing. But right now, they're perfect, and things are great. But I'm using this to illustrate. If you go to this kind of maximize, like it looks like it's maximized and it's actually covering the whole page. But if you click on maximize, you actually get a whole bunch more information down here at the bottom. I'm going to kind of do a little movement to make this a little smaller. So here are the different dimensions, right? So we have 3 values in our model effects. So I have 3 columns. Here's my how many people I've read in. So I had 3,333. I only read in 3,330 of them. So I have 3 missing values. Here's my training and my validation, the size of my samples. It's going to be that 60-40 split. If I click on the overall ANOVA, this gives me that overall F-test. Right? So is there a significant difference? Absolutely, and the R-squared's off the chart. The fit statistics, which is more the things that we're looking at, and kind of what I went through up here. Here's a table of all of them. Right? So that root mean squared error is practically non-existent, which was great. The parameter estimates. Right? So this is where we get to start making our equation. Is everybody good finding this? So here's where we make our equation, right? So our prediction is going to equal basically an intercept of 0 plus basically 0 for the number of calls plus 0.269. So if we really wanted to, we could round that to 0.27. For the number of minutes that you spend. So really the intercept doesn't matter. The number of calls doesn't matter. What really matters is that it is 27 cents a minute.
Is that line on the fit summary your alpha level?
Yes.
Is there a way to change that if you wanted to?
Absolutely.
I could just,
It's that easy. So yeah, so here's an alpha, and the only thing is like it doesn't quite give you, like there's no like, well so here's 0.01. So yeah, it doesn't tell you exactly where it is, but it has its cutoffs. So like here, if we wanted to figure out what we would need, the alpha level we would need.
Keep up road, it says.
Right. So here you need an alpha level of almost 0.1. No, I guess you need an alpha level of almost 0.3 to get international calls. So there we went. So we just figured out 27 cents a minute for all of our callers. But what was our question?
Taking a plan,
Right, so now we can take it that next step. So if I have an international plan, does that change that 27 cents a minute? So now, yes?
Sorry, what does this graph show exactly? The assessment graph? The one with the predicted and observed average? What is the y-axis?
So the y-axis is the percentile of data that we have available to us. So when you have, let me do this. So let me do this real quick. So our predicted is 0.27 cents per minute. So what your assessment graph is showing you, and if we really wanted to look at any of these graphs, see if I can make it work. Nope, just kidding. Sometimes when you click on it, it brings up this other little, and it'll let you like pop one out. But so for this, what we're looking at, this is the percentile of data. So we start with none of our data, and we're up to 100% of our data. The y-axis is the predicted average, and then it's also the observed average. Right? So when we're predicting this, the average winds up being, I'm just not sure I do this right. So here we have the 20th percentile, our average changes a little bit. Here we have the 35th percentile, and our averages are going down. Predicted average is going down, predicted average is going down. And by the time we get it, here we have 100% of our data, and we've predicted them all with a 1-point accuracy. So I'll show you here in, let's see if I can, So if we go into the options, since you're asking about this, I have a couple of slides on here in a second that will probably help. So here's our assessment plot. So right now, the plot that we're looking at, it's not going to tell me. There's a couple of different plots, and now I'm going to have to go and look and figure out exactly what it is. It's either going to be a lift plot or a, it's not going to be a rock curve yet. This is probably lift. So it's the amount of data that we're actually showing. So here, our accuracy stays, like I said, just right next to each other. So really the big thing we're looking at is just how close are the two variables together. So I'll have a much better answer for you. So let's see. Other questions?
Do we need to understand the residual plot?
No, the big thing that we're looking at for the residual plot is just, do we see a pattern? Right. So if we see a pattern, then we're going to say that's one of the things that has an error. We have to kind of go back and check. But as long as there's no pattern, then life is good.
What would you want to fix if there was a pattern?
Depending on what the pattern looked like, one of the most common things to do is just to standardize our variables. Probably one of the first places I would go. And then it would also be, do I see any like potential data issues? So really, I'd probably do data issues and then standardize the data. Alright, so let's go ahead, let's go back to our business question. Does the international plan matter? So if we go back to the roles, and if we add in, this time we're going to add in a classification effect. So there's a couple of different ways we can do this. We can filter the data and just make two models, one for international plan and one for not. Or we could potentially add a classification and say, hey, does international plan matter? So that's what I'm going to do. I'm going to say, does international plan matter? I'm going to put that into my equation. I'm going to click OK. And as we do that,
So if you're going to maximize you do that, it under parameter estimates for international plan, yes. It just has a, looks like it's null value. Is that an error?
so the problem that we're running into, this is a great point to bring up. Right, so what does our international variable look like? Like if we went to the data set, what do we see? We see yes or no. Can SAS do anything with yes or no? No.
So
Why does it have numbers for international planning?
Oh, it does. Okay, so now I'm seeing. So I take it back. So this is the great thing about visual analytics. It's the great thing about Enterprise Miner, and it's the great thing about SPSS. So remember in SAS Enterprise Guide, we had to create dummy variables. Right? We don't have to create dummy variables anymore. This will take care of it. So what this has just done is it has created a dummy variable for us. And what it's telling you is that 0 is yes, and 1 is no. So the parameter estimate for if they have an international plan yes is 0. And so it's not going to fill the rest of this in because it's really just looking at this one.
What is the control variable?
Yes is the control variable.
So will that always be the case then when it automatically creates dummy variables for you? One of them will just be 0?
It'll always be the case, and in fact, alphabetically, the last thing that comes alphabetically is going to be the control variable. So that's the bad thing. When you let the software create it, then you don't have control over what's your control variable or not.
And so in that case, when you're thinking about creating like a model and equation, you just have to kind of think through the fact that the baseline for this is
Yes.
an international plan or whatever.
Right. So here the baseline is that they, I guess, do have an international plan. So if you want it to be the reverse, then you would want to actually add a dummy code and say international plan 1 to this and 2.
you can't change the default.
Not that I have found. Now I won't say that you can't. I've played with it a little bit and I haven't found it yet. There's a great chance you can. I just haven't found it yet. That's going to be my answer to a lot of things. It's like, not yet. Maybe. If you can find it, let us know. So in this case, does having an international plan change how much you have to pay per minute for international calls? It doesn't.
Which is kind of what you would expect, right?
Well, I would think so, right? Because if I sign up for an international plan, the whole reason I'm signing up is so that I get cheaper international calls.
Well, that's kind of what this is saying, though, because if you don't have an international plan, your price is, I mean, very minimally, but technically increased.
By 2,000?
I mean, very minimally, but
Well,
technically.
one thing I did was like,
You go look at the average.
one thing I did was like the correlation matrix or whatever that was, and it showed like and we could do it here too. Whereas like it's basically like it's a 1-to-1 relationship between the minutes and the charge, and that's including yes and no, which means that's the same for both, right? Like,
I would think so.
logically.
Right, because if not, you would think that yes would have one line and no would have another
It'd be
line.
a little different.
And it'd be different.
Right, which doesn't make sense. It's like, then what's the point of getting a plan?
Probably the point is that this only tracks calls which we make. Incoming calls will probably be charged if you don't have an international.
Maybe so, right? So maybe we don't have all of the data that we need, right? It's an incoming call or an outgoing call. So maybe we need more information like that. So
Maybe there's some other benefit if you get an international plan that's called 2.5 per hour or something like that.
maybe.
You can't really account for it. Data.
Right. So this is things, so these are questions. It's like, well, now, like, based on the data, it doesn't look like there's a change in price. Let's figure out why.
Is it the landline or mobile phone?
I don't know. Well, no, I told you, right? Like, I found the data and it was great and it was wonderful, and then we've looked it up and I've asked people and they're like, yeah, whatever. It's a data set. So I do have, and I think next week we'll probably use it. I have a more recent telecom data set that actually has like hundreds of variables. That actually has like answers, like here's the incoming, here's the outgoing, and it has all that extra stuff in it, and we'll play with that a little bit. But yeah, so in this case, just answering the question, does it matter? No, it doesn't. And then we can start to get into the business side of, so what? And how can we use that information?
So this one is there a way in this to like, if we added a whole bunch of continuous variables, is there a way for it to filter out, find the best fit or best model?
Yes.
Because right now we just selected the one. But if we added a bunch of other ones, would it just throw those out?
Yes.
Go back to the one. But how?
So, I don't know why I can't slow down. So, if we go back to objects. Oh, because it's maximized. Okay, so I have to take it back off. So, unmaximize it. So, this is page 2. So, if I was to change this, and so the question was, if I've added a whole lot of other variables, like let's say I wasn't really thinking about this. So, I could actually go through and let's add account length and customer service calls and voicemail, the number of voicemail messages. So I'm just adding some other stuff. And I click OK. And it's basically going to say, yep, doesn't really make a difference. So if you look at, if we maximize it and look at our parameter estimates, then you'll still see that 0, 0, 0, 0, really 0.
So we would just we would have to know that we can throw this out.
Right. So we don't. So this doesn't have.
Because the other ones, they automatically.
They can automatically throw them out for you. So they have that variable selection option. And SAS via Visual Analytics does not have the variable selection option. So it will do stepwise. So next thing to look at is let's do that. Let's do some forward, backward, stepwise. So if we go back to, again, so a lot of these times we'll have to unmaximize to get back to being able to do things. So this was, and so I'm going to rename this page, and I'm going to call this none. Okay, so this just had all the variables that I wanted to try. Well, now I'd really like to do this again, and see if forward, backward, stepwise would make a difference. So instead of having to recreate it with a new page, if you right-click, or if you just click on the three little hamburger dots, I don't know if you guys, you can duplicate the page, and then you have everything set up how you want it, and you just go change one extra piece. Right? So that's kind of a nice feature. So here what we're going to do is we're going to go change to the data roles.
Before we proceed, can you just remove international minutes? And I just did something like that, and the assessment charts just went. There's a
Go
blue
crazy.
line, everything is like.
So if you...
Because that seems to be the most influential.
Right, so there's a direct correlation between international minutes and the international charge. So we just wanted to look at other things to see if we could predict the international charge. So we could go and remove international minutes. And then this happens. Right, so your predicted average we would want to cover here, and your observed average just goes crazy. Right. And so that's because this isn't a good model. These variables are not predicting international charge at all. So yeah, so we could definitely do that.
So earlier, like with the minutes included, those two lines are basically the same.
Because it was a perfect prediction.
Okay.
When it's not a perfect prediction, then this is what happens. Things that you're going to look for. You want the craziness of the training to match the craziness of the validation. Right? So that's what you have here. So they don't have to be a perfect match. And we'll actually, here in just a second, we'll try the Boston housing data, and it has some better variability. Like I know the question that I was asking was fairly straightforward, right? So we'll do something with a little bit different. In fact, let's just go ahead and jump into the Boston housing. And then we'll do the forward backwards on the Boston housing, and it'll make a bigger impact. Yes?
What is creating a pipeline?
Don't push that button.
Did
you push that button?
No, I did not.
Did you push the pipeline button?
I pushed it once earlier. It's very confusing.
Give me a second, we'll push the pipeline button.
Okay.
Okay. So, here we answered our business questions, right? Can we predict international charge? Yes, we can. So we saw some of the features. Did international charge or did international plan matter? And so we're just kind of asking business questions, answering business questions, seeing what happens in the software. So this time, let's go. I'm going to go pick a new data set. So, now things you can do here. If you change data, just right here, you add a different data source. Let's see what happens. Is it going to give us a whole new... I don't know. So Boston housing with my initials after it. Everybody happy with Boston housing? Sure. Sure. It should be available for you. It's in the public. Data should come up. There's all sorts of data. You'll start to notice. I'm just going to go ahead and click OK.
Did you open a new page, or are you doing it?
So I didn't do a new page. So this is what I want to kind of illustrate here. So I didn't do a new page. So now the data's there, but I'm still having all my data for the other. So we either want to create a new report. At the very least, we want to create a new page. Okay? So if I was going to save this report, I would probably save it as today's class. All right, if I was doing this for a homework assignment or something else, I would probably want a new clean report to work with. Okay, so I'm just going to do a new page, and I'm going to rename it. I'm going to do Boston housing, so I can tell that it's different. And I'm going to use none as a comparison. I'll show you why none here in a second. So the thing that we're going to look at, so we pull our data in, and we have a whole bunch of measures. Right? Well, everything's either, it's a number or it's 0, 1. But a couple of these are actually categorical variables. So if you will change the cat.medv, change that to a categorical variable. you will scroll down and if you will take, oh, sorry, yeah, scroll up, the chas, right, so if it's on the Charles River or not, and change that to a categorical variable. Those are our two categorical variables. And so our goal is going to be to predict the median value of a home. So we're going to skip the data exploration. We're going to go straight into, let's look at this. So I'm going to go to Objects. I'm going to scroll down until I find my linear regression. I'm going to pull the linear regression over. So my response variable is going to be MEDV, the median value. For the continuous effects, I have no idea what's going to affect it, so I'm going to select everything. So I click the first one, I click the last one, and it selects all of them. Unless you just really like to be click happy. So I'm going to select all the continuous effects. There's some stuff happening.
How
do you not select all? So you click the first one, hit Shift.
Shift.
My bad. Apparently I left a word out. I did it on my so Control. So if you hit Control, you're only going to click one at a time. If you hit Shift, then you can, if you hit the first, Shift, and the last, it'll select all of it. Silly keyboard shortcuts. All right. So we good there? So you've all got your continuous. So what about our classification effects? Can I add both of those?
There are no.
Okay, so the top one is the median value of a home if it's either above or below $50,000 or $100,000. It's something. I don't really cut off.
Jake's got something different.
Yeah.
Jacob has something different.
Yeah, mine too. Same number of observations.
Same number of observations.
Different R squared. Different bars for the variables. Summary.
So what do you have for your?
Each response different.
So go back to the beginning. So what do you have for your response variable? Median value. And then when you did your continuous variable, how many variables do you have?
I think median value has been selected in continuous also. That's very important. If you selected it.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
When you click add, it comes with up.
Well, now I got nothing. I realized I should do something different. So, for your response, did you do the cat?
The only thing that I see is the order is different.
Like continuous.
Mine is backwards. Sorry, that's a lot.
Shouldn't matter. Okay. Remove them and try again and see if it does matter. Wouldn't it though?
How did you do that?
Oh.
I think if the values are same, it's something for different.
I
As long as the values are same.
Ah, okay, there you go. We're gonna get there. We're gonna get there. All right, so you have your response, you have your continuous. So now for the classification, can we add both of them or just one of them?
I'm gonna go with.
It'll let you click on both of
I'm
them.
gonna go with one.
Should you add one or both? Since I'm asking the question.
I'm gonna go with one.
Okay. So this is the median value, what we're using as our target variable, as our response variable. It's the same variable, the only difference is the one that we're using right now is continuous, and this one I've categorized into above a certain value and below a certain value. So we don't want to double use the variable. Okay, so don't include this cat MEDV Just include the Chads. Just include if it's on the river or not. And so now we'll notice that we haven't created our partitions yet. Right? I jumped the gun. I forgot to create my partition. Right? What do I have up here at the top? Bring the data in, verify the data types, make a partition. So we're going to go back and make our partition. And it's okay. So if you forget, you just don't do it. Not a big deal. So we're going to go back to data. We're going to add a new item. Partition 60. Click OK.
We're always going to use 60 basically.
I do. You're welcome to change it just to see what happens. But I just 60/40 is kind of the default that I use.
You have to go to partition ID.
So it'll go in the partition ID. So now if you click back on your linear regression, now you can add the partition ID. And now it takes everything that you had and it splits it. And this is where these assessment graphs get more interesting. So let's kind of look at some of the visual aspects, and then we'll go to some of the numerical aspects. Okay. So the first thing we have is we have this, again, it's the validation average squared error is what it's defaulted to. I like the root mean squared error just because I like the interpretation of it a little bit better. So, because here I can really interpret that, okay, my average, on average, I am 4.8. So in this case, it's thousands of dollars. So my average residual, how far I'm off, is about $4,800.
So,
yes.
Is that going to be different based on your partition, just randomly?
It does, yeah, so it'll change just a little bit. Right? So when I had it and we did it in Enterprise Guide, and I had it on the slide, right? I used all the data, and we had our root mean squared error was like $5,100. Okay, so now here, I'm looking at the root mean squared error, and I'm looking at it, because it says observations used as, do that. The root mean squared error should be for the validation. So it should be for this validation. So for our validation, now it's about $4,080. So still, we're okay. You guys are having way too much fun pushing buttons, I can tell.
We're trying to figure this out. Like we have different. Okay, we guess it's like the way that it partitions data.
Yes, like very
Yeah,
different.
it's like it's extreme.
Yeah.
Well, and then anything, because we've started, anything that you played with on the other option is still set. So like if you were playing with stepwise, or if you were playing with any of the other types of methods, that's set. So we notice that over here. So that's the thing. And so a lot of the times you'll see that I will start a new project, and that's why. Or start a new report. So then it's like I know everything's clean and I know exactly what I did, and there isn't something. Because the one bad thing about this program is that residuals, leftover stuff, things you've already done, stays unless you start a new report. All right, so we've done this. We're kind of looking at it, and I said none. So here I'm keeping all of the variables. I'm looking at all the variables, and I've got a $4,800 kind of range here. Now let's go, and I want to do this again, but I want to use, let's use stepwise regression. So I'm going to take this, I'm going to duplicate this page. I like what I've done so far. The only thing I want to do is I want to change this. So I'm going to rename this page so I know it's different. So now this is my Boston housing, and I'm going to call it stepwise. Boston housing stepwise. So now I'm going to go into my options. And in my options, right here I have variable selection. Right now it's none. That's kind of the default. But I want to change that to stepwise. Okay, sure. I'll change it to stepwise. And look, these variables right here, I don't think you really need. Okay, so in the options, I'm not going to change anything with how it looks, so I'm just going to move down to the linear regression options. And I'm going to change this to stepwise. So now I've gotten rid of some variables. And now my root mean squared error, it's still 4.8. So getting rid of those variables didn't seem to have a real big impact on my prediction.
So how does it determine what the significance is?
It's based on graph level, right?
Well, I mean, if you slide the thing over, it doesn't matter.
No, if you slide it over, it doesn't remove it.
Because, like, for mine, like, so like, if you wanted to do a 0.01 value, like, there's still two variables that would not meet that. So how do you, like, change? Can you change?
I don't know that you can.
So it's just like...
You would use this to get, like, an idea of what you want to do, and then you would still go and manually remove those other two variables.
Like the selection criteria?
Oh, the selection criteria. You can change its significance level, and then change it to 1. And so that was stepwise is going to go in different directions. So like you'll let people in and out at an 01 criteria level. So yeah, so all of these different things you can play with. We could, if there's a drop-down menu, look at it and see what it is. If it makes sense, use it. If it doesn't make sense, Google it and see if you want to use it. There's going to be the standard ones that we're going to use. You know what significance level is. We're going to focus on the root mean squared error. But if you want to know what the AIC is, go Google it and see what you want to do with it. Okay, the AIC is pretty specific, or just wait and hover over it. It's the like this one's a measure of discrepancy between the true distribution and a specified distribution. So the AIC works if we're doing linear logistic regression. It's not going to work in our later models, so it's not something that I work with a whole lot. Okay, so now we have a stepwise. So we have all the variables, or we have a stepwise.
Can you explain stepwise doing it?
Yeah, so stepwise is just basically, we start out with no variables, and we find the most significant variable, and we put it in. And we find the next most significant variable, and we put it in. And the next most significant variable. And if for some reason when we put in this third one, if it actually makes the overall model R-squared go down, then maybe we'll kick it out. And then we'll try the next one. And the next one, we can always put things in and take things out.
Okay.
So
Things being variables.
at the 0.01 significance level, I have 4 variables, and you have 6, and you have 3 different. So you have, I have one that you don't have, and then you have 3. So is that based on the partition? I don't see it.
It could be based off the partition.
That's really variable.
I wouldn't think it would be that variable. Like normally the top. So which variables do you have that are important?
I have, so the LSAT, like the GIS, and the and I have chat.
Really?
Yeah.
So in this, I still kind of go back to the what all have we played with, and have we played with the exact same things? Like, have you guys changed anything different than I have?
Yeah, I've got all the same as you, except I don't have knots and I do have chats.
Yeah, I've got different stuff too.
Different stuff. So part of it can be the different, the different partitions can make a little bit of difference. It shouldn't make that big of a difference.
We don't have enough observation.
We do, I mean, for this we do, well, for linear regression we have enough observation. Well,
Maybe use different.
We're a little bit small just because of the number of variables that we have.
Maybe use different combinations.
It shouldn't make that big of a difference. I mean, hopefully, the idea is that we're going to find a model that's going to work.
Very high, but mine doesn't.
Well, so let's see.
I mean, you did all say we'd all get different
And
answers.
you will get different answers. It shouldn't be drastically different answers. I mean, since we're using the same data set, it's all cleaned the same way, it should be, like, the values will be different, but the most important variable shouldn't be that different.
For example, in mine, chance is significant, B is not. For you, B is significant, chance is not.
Uh-huh.
For her, nature is significant.
There's a really wide variety that I'm not expecting. So, like, if we were doing this in a different program, I would not expect this at all. So this is concerning me a little bit. I'm not gonna lie. I've never done this live with a class before. So this is gonna be something I'm gonna have to go investigate and see what's happening. The point that I'm gonna care about, so let's do a couple different things. We have an academic piece, and then we have a transfer to the real world piece. So from the academic piece, the thing that I care about is whatever your output says, can you interpret your output? The transfer to the real world piece says if I've got 3 people on my team working on this, why are we all getting different answers? And that is going to be my homework, is to figure out why we're getting different answers every time we do this.
What do you think the explanation is around just different partitions?
The different partitions shouldn't make that big of a difference, right? The whole idea behind the partition is that we're going to come up with a model that's going to work with new data, right? So it shouldn't be that big of a difference. Like the importance, like like we're going to look at our equation. Our equations are going to be different, right? You're going to have different values. The equations will look a little bit different. But the fact that one variable is important in one data set and not in another data set, that's more what I'm concerned about.
His assessment's a lot further away from the predicted than yours is too, though. Which makes me think partition couldn't make that much of a difference.
Yeah.
But if we're following kind of step by step, like how did that? Because our partitions, Simon, did you change the random seed for your partition?
I didn't click anything.
Right, so like had you changed the random seed for your partition, then I would agree with it a little bit more. But if we're all clicking the same buttons, using the same data, we should be getting very similar results.
And probably the top 4 variables are explaining so much of the model that the other variables are totally not there.
Which makes sense, except for the fact that like here I have the DIS as one of the top 4 variables. It's explaining a whole lot, and Matt doesn't even have that in his.
Oh,
yeah. So I totally agree with that. You're like, these are the variables, and then okay, right? So if like age was hopping in and the B wasn't, and different things, but the fact that something that I'm looking at is like totally significant, and he doesn't have it at all.
Do you think so when we did the partition, like if we clicked the random number, if we all put in the same numbers, do you think that would make a difference? Maybe I'm misinterpreting what that means.
I think it could. My assumption was that the random number would stay the same.
Okay.
If you don't add in a random number, but we may. Not this time. I'm going to go play some more. But when we learn logistic regression, doing something very similar, we'll try that next time and see if that does. So, like, if we all put 1, 2, 3, 4, 5 as our random number, then do we all get the exact same partition? So I assumed that we would, and that's why I told you not to pick a random number. But maybe it has to go the other way. Maybe we do have to pick one to make sure we're on the same page.
Yeah.
So. It does, but again, it still worries me that we don't all come up with the same top 4.
Yeah.
Right? So it's one thing if, kind of like what Harry was pointing out, right? So like when you get down to like the 6th, 7th variable, if age is important for me, but being next to the river is important for you, but it's really not that important. I can see fluctuation there. But the fact that like my fourth most important, and it's saying it's very, very significant variable, isn't even making the cut on yours, that's where I'm starting to get a little more worried.
You can do something to collinearity.
And even with the collinearity, there's not a whole lot of collinearity in this data set. But even with it, it shouldn't be that dramatic. So, fun times. We're learning. Have you learned some stuff today? Right? And some of the things that we're going to run into is like we're going to ask some questions that we're just like, but why? Okay, so it's not, so kind of what I hope that you'll do is we have a tutorial, right? So SAS Enterprise Miner or SPSS Modeler, either one of those, we've been using these for 10 years at various version levels. We have great tutorials. We have pretty decent tutorials on how to do that. So as far as following and being able to execute, those are going to be good for you to do. This is going to give us a lot of time to, well, I don't know, and what if, and how can we figure it out? And Dr. Keeper has homework, and we'll come back with answers. But kind of give us things to look at. Yes?
I just looked up. I still don't think it should make that much of a difference, but for SAS-FIO, if you don't specify a number for the seed, it generates a random seed based off of the system clock.
Oh, jeez. Okay. So good,
So,
but still problematic.
depending on how specific that is, it could still, generate very different seeds.
So even if it generates a very different seed, I'm still concerned at the drastic different answers, though. And we do, so we have, so we only have 500 observations, and we do have 13 different variables. But kind of rule of thumb with regression, as long as you've got at least 10 observations per variable, then you're still doing okay. So as long as we have 10 times 12, so we still have enough that we shouldn't be running quite into this problem.
Is the observation used, is that 500 total or 500 for the training?
That is a great question. Let's find out. Yes.
In the roles there, can't we just remove the partition and see if our numbers?
All get the same thing?
Yeah.
Alright, why are you trying to be so smart, Jacob? So if we take the partition away, we'll remove partition. So 506 total. So the fact that we're 60-40ing could be an issue.
I get the same exact number.
So everybody's the same? Yeah. So the issue is the partitions. Ew. Okay, so now what does that bring out? How comfortable do you feel now with this partitioning idea?
Just go back to the record.
Go back. We don't need this at all. Alright, so the fact that our partitions were giving us some pretty big different answers.
I mean, can we just not look at it stepwise and make our own judgments on what's important and what's not?
Oh, absolutely.
We're getting different numbers because the program itself is kicking out variables. Can we just look and see what, the p-values are for different variables and how impactful they are?
So that's absolutely one way to do it, right? So using the regression, just making your own determination is absolutely a fine way to go. We're introducing the stepwise and the different methods as different variable reduction techniques with the idea of, so this was stepwise, and what did stepwise throw out? And then if we start to look at forward, which variables does forward fall out? Which variables does backward fall out? And amongst all of those, which variables are staying no matter what model we use? Those would be the ones that I would actually model all the time.
So if you added the partition and then took off the stepwise, that's easy.
So if we add the partition, things change. The fun thing though is like our root mean squared error is not changing much. Right? And if we take off the stepwise and just make it none, still going to look different enough.
I saw the 4 though. Like the DIS is in there for me this time.
So
But
now the
then-
top 4.
But then, yeah. But my rad is like is higher than the Knox. Like
So
it's
there's
pretty
still some
significant.
variable in
Yeah.
there.
Yeah, I mean, you look at me, like, crime rate is pretty low for me, but.
Alright.
For me, low for you.
So let me show you one more thing before our time runs out. I love this. It's like, my whole intention was to let you guys out early today. I didn't think this was going to take that long. But I hope we've learned, I hope we've had some discussions, and we're going to continue to have these discussions throughout the semester as we try all these different techniques. So we're actually going to be back in SASVIA next week. Instead of looking at logistic regression, or instead of looking at linear regression, we're going to look at logistic regression. The one thing I do want to show you that you can do is like here I can add, and I'll do this in more detail next time. One of the objects I can add is a model comparison node. And then what this will do is that, so I don't want international charge, so this is actually not a good one. But if I wanted to do international charge, those are the first 2. Oh, this is my turn clean data. I don't want that one. I want my Boston housing data. So my Boston housing data, I'm looking for the MEDV, that's my variable. I have 2 linear regressions. I have one that's none, one that's stepwise. And so if I select all of these, what it will actually do is it will compare the fit statistics. So here this is the average squared error. I would change that to the mean squared error down here at the bottom. So here, none has a slightly lower root mean squared error than using the stepwise. Here you can see the different variables and their relative importance. And so here you can actually compare the different models and see which model you like the best. Or, in this case, which variables come out through all the different models.
Wait, how did you do this?
So, there's a tutorial. We'll do it again, but really it's objects, it's a model comparison, and just drag and drop. And then it'll pop it up for you. Alright, so things that I would encourage you to have some fun with. Let's go back to step 1. If you want to create a pipeline, we'll play next time. This is the place that I don't have tutorials for yet. Okay. So what creating a pipeline does is it takes what you did. So this is taking us out of visual analytics and taking us to this modeling studio. And what this modeling studio is going to let us do, as soon as it creates a project, is this is going to give you a look and feel that's more like SAS Enterprise Miner. Okay. So it's already bringing in the pipeline. So it says, look, you have some data that you brought in. And then you did some linear, interactive data preparation. You did some data things, right? We changed data types. And then you did some linear regression. So you did that. And then you did some model comparison. Well, that's great. Okay. So there's some things that we're going to be able to do. I might want to, below my data, maybe I want to do variable selection. So in Model Studio, you can do these variable selection ideas. It does all, it's going to look so pretty. It's going to be fun. We'll play with this as the semester goes. Okay, I don't have tutorials for it yet. I'm not totally ready just to show it at you. But you'll be able to do the variable selection, the variable cleaning, and then you can actually save this as, and you can save it out to your CAS library and then open it back up in Visual Analytics. So it's a lot of back and forth. So VIA is this big collection of things that we're going to be able to play with different pieces. Again, we're in week 3. We've got 16 weeks to go. We'll play with a lot of stuff. We'll do a lot of fun things. As for now, let's make sure that we've kind of, without doing and going through the slides, we've really talked about our performance evaluation. We've talked about the fact that I really like the root mean squared error. The lift and gain charts we'll focus on next time. And I'll kind of explain what those are. So right now we added in, which one should we pick? If we're supervised with a continuous target, we've got linear regression. Somebody was asking, hey, we're going to do A10. I told you guys a concept map, and I told you I'd give you an example of what one of the students did. This was by fantastic student. This is way, way, way above and beyond Call of Duty. Okay, so, but this was it's a concept. This was his concept map. So most students will do like kind of this piece. Sorry. So most students will do something more like that piece. Like, oh look, it's supervised and unsupervised and continuous and categorical. And kind of break it out that way. This person just happened to go a little bit farther and start to say, well, here's the goal, and here's some information, here's some things to consider. You can make yours as detailed or as not detailed as you wanted, but I promised I'd give you an example. There it is. If you have questions about your project, about the data set you're working on, let me know. Next week, quiz 3 over linear regression is due. Assignment 3 you got 2 weeks on, so you can start it doing the linear regression part, and then we'll finish it next week after we do logistic regression. And that's all I got for you. Questions, comments, stay, hang out. If not, I will see you on Wednesday.
I figured out why they're saying I have to read for every category experience.
Yes.
So I delete I delete that row.
I just missed that. I was like, oh, no one else saw it. So, no, I mean,
1 minus 1.
so I yeah, so I sent it as like
I don't know, like,
In enterprise minor, I can tell you that.
like when I do like format tables, it's like a screen on the computer, you didn't have that format. So like Excel,
yeah, or else
it's still and so again, I have really like his second I got you really quick.
You didn't want to do that?
yeah, it'd be better to know what we work on it.
Even you and maybe cheaper labor, the laws are
Well, we can look at I sent that one in. So basically, if anyone else has